Okay, welcome to this physical sciences lesson. You'll have to bear with me, it is my first time using this technology, and I'm just sussing it out, and there's some things I haven't quite figured out how to do yet. So, we are starting criterion 5, which is force and motion. So let's get straight into it. Okay, so firstly we're going to look at the difference between scalars and vectors. And this example here outlines that really well. So if you're bushwalking, you ask someone what the temperature is. They say it's 5 degrees Celsius. You say, okay, that's fine. It's really cold, but that's fine. You know what they mean. If you ask them how to get to the next hut and they said walk for 5 kilometres, you'd be confused. You'd be like, which way am I going? You might go north, and it turns out it was south. That's not good. So, what we're saying is that some things need direction. Direction is very important sometimes. Other things like temperature don't need a direction. So, that's the difference between scalars and vectors. Scalars are physical quantities. So, it's a magnitude, which is the number, and the units, like kilometres for example, and a vector has both of those things but also has a direction. Okay, so scalars, magnitude and unit, vectors, magnitude, direction and unit. So here are some different examples of some scalars and some vectors. So scalars include things like distance, speed, time, energy, etc. You can see the list there. Vectors include displacement, which is distance but with a direction given. Velocity, which is speed with a direction. Acceleration must have a direction. Force, weight, because weight is a type of force, it's not the same as mass. And momentum. So some of these things we haven't looked at yet, force, weight, momentum, they'll come into the course later. But they are examples of vectors. In terms of notation, if you want to do really lovely notation and do it properly, we should have a little arrow above anytime we have a pronumeral where we're talking about a vector. I often skip that because I can't be bothered. I feel like if you're in Pete's class or maybe Ben's class, they might not like that. They might like you to have the arrows. The most important thing is that anytime we're talking about a vector, we need to have our direction. That is the most important thing. Okay, let's keep going. All right, so addition and subtraction of scalars. You guys have been doing that since primary school. Adding masses, subtracting masses, it's just adding and subtracting numbers. It's not very exciting at all. Okay, addition of vectors. When we're when we're adding vectors, we need to consider the direction of the two vectors that we are adding. Generally, we need to define a direction as positive. Okay, so let's have a look. Yes? Okay, I think we're recording again. I just had a visitor. Hopefully this is working. I'm really not sure. Anyway, I can't remember where I was. Let's go to the next slide. Okay, here we go. All right, so we are adding vectors. When I have two vectors in opposite directions, I need to define a direction. So here I've got north and south, they are opposite, so I'm going to define north as positive, as per convention. So define north as positive. That's shorthand for positive. Shorthand for negative is that, just so you know. Okay, so now we're just adding them together. So what is their final displacement? So for displacement, we use S. if we're doing everything properly, we put a little arrow above it. So the displacement is the northerly component plus the southerly component. Now, because we've defined north as positive and 14 kilometres is in the southerly direction, we subtract, oh hello, what's happened? We subtract 14. So 6 minus 14 is -8, and that's metres. And we've defined north as positive, so our answer is north. But instead of writing -8 metres north, it makes much more sense to write just +8 metres south. Okay, next. Okay, so here again we're looking at the two directions and we've got left and right, which are opposite directions. So let's define one as positive. Convention would be to define right as positive. I'm going to define left as positive this time, just because I can see that the larger number is left. So define left as positive. So we are talking about force here, which is measured in newtons. So force uses the letter F. So the force is, so the left component is 500, and right, which is going to be negative, is 200. So 500 take away 200 is 300 newtons, and the answer has to be left because that's what we defined as positive. So those are fairly straightforward so far. Here's where we get into some lovely trigonometry, which is a really fun time. Okay, we like to use a ruler here, and we like to label everything in a lovely way. Here we go. No, I don't want to look at that. That's boring. Let's just do our own. You guys can read that by yourselves if you want to, but if I just read it to you, we'll all tune out. All right, a plane flies 800 kilometres north followed by 600 kilometres east. Use a scale diagram to calculate the plane's final displacement. So we've got 800 kilometres north, 600 kilometres east. So those are not opposite directions. So we can't just define one as positive and subtract them or whatever. I think the best way to do this, so we always like, when we're doing sort of like, if we're writing coordinates or whatever, or if we're writing like a direction, and then it's like northeast, we write it as northeast or southwest. What I'm trying to say is we put the north or south first, and we put the east or west second. So to make life easier with these, rather than doing them in the order that it says, it's going to be easier to do the northerly component first and then the easterly component. In this case, they are in that order anyway, but if they were written in the opposite order, I would still put the northerly component first. It just makes life easier when we get to our final answer. So we do arrows head to tail. So if I'm going to go 800 kilometres north first, north is this way, and of course I've used a ruler. 800 kilometres north and 600 kilometres east. So now I do my easterly component coming off the head of that arrow. Oh, sorry. Oh my gosh. Sorry, if I knew how to crop this video, I would, but I don't. So that's fine. It's working now. Okay, 600 east. Now our resultant vector is from the start to the finish. So it's important that we put a resultant vector in using an arrow, not just a line. So we go from start to finish. Okay, because our displacement, we started here and we've ended up here. So that is our displacement in that direction because we've gone from here to here. Okay. And that's what we're trying to find. This, oh my God, sorry. This displacement, and displacement is the letter S. All right, so we've got a nice, lovely little bit of Pythagoras here, which is fun. So hopefully we remember how to do Pythag. To find this bit here, that's the hypotenuse. So for Pythag, I think it's, what is it, c squared equals a squared plus b squared, where c is the hypotenuse and a and b are the two short sides. So here I'm trying to find the hypotenuse, so I'm going to go s squared equals the short sides, each individually squared. So 600 squared plus 800 squared, which, what does that give me? Let me just pop that into the calculator very quickly. 600 squared plus 800 squared, oh gosh, that's a big number, is 1 million. Okay, but that's s squared. So to find s, I need to square root 1 million, don't I? You don't need to show all this working every time you do one of these. It's just, it's the first time I'm doing it with you guys, so I'm going to show all my working. So the square root of 1 million is 1,000. So that's 1,000 kilometres. So my displacement is 1,000 kilometres. So from my starting point, I've ended up 1,000 kilometres in this direction. Now this is the displacement. It is a vector, which means that the direction is really important. I can't just give 1,000 kilometres as my answer. So I need to include a direction. And the other thing that we're not allowed to do is we can't just say northeast. We have to be specific and give the angle. So we're going to have to actually calculate the angle. So how far from the northerly direction have we gone towards the easterly direction? Okay, so it'd be north so many degrees east. So calculating theta here, we need to look at SOHCAHTOA, which hopefully we've done before. Now these are on your formula sheet, the three different ratios. We need to start by labelling the sides. So we know that the long side is the hypotenuse. The other two sides are called the opposite and the adjacent. And like I said, hopefully you've done this. I think it's in the grade 9 maths curriculum. So opposite is opposite our angle. So we can see our angle is here. Opposite that is the 600. Adjacent means next to. So next to our angle is the 800. So that's adjacent to our angle, but not the hypotenuse. So it's the short side adjacent to your angle. Okay, now I want to find theta. I can really use, I know all three values, so I can use the adjacent, the opposite, or the hypotenuse. I'm going to use the adjacent and the opposite. It's the one that you have to sort of use most often. And just in case I got my hypotenuse wrong, I know that this is definitely 600 and that's definitely 800, so I think it's safer to use opposite and adjacent. So the equations, which hopefully you've seen before, otherwise you might be a little bit lost, but they are tan of theta equals opposite over adjacent, cos of theta, cos of theta equals, which one's cos? So it's going to be adjacent over hypotenuse, and like I said, these are on your formula sheet. And sine of theta then is opposite over hypotenuse. Okay, so because I've decided I want to use the adjacent and the opposite, I'm using the formula that has adjacent and opposite in it, which is tan theta. And I'm solving for theta. So I go tan of theta equals the opposite, which is 600, divided by the adjacent, which is 800. And I need to solve for theta. So I don't want tan theta, I want theta. So I need to do the opposite function for what tan is, as to get that over to the other side. Now the opposite of tan is inverse tan, or arctan, which on your calculator, and the way that we do it, oopsie, sorry, I'm putting it over the other side, that removes it from the left-hand side. And so on the other side, we get inverse tan of whatever was already over on that side. So this is fairly mathsy. If you're struggling with this, I recommend having a look at a YouTube video of just doing some basic SOHCAHTOA. So right angle trigonometry. Because we sort of assume that you know this stuff in Phys Sci. So while I do go through it, I'm not going to spend ages explaining it in great detail. Okay, so if I put inverse tan of 600 over 800 into my calculator, I get 37 degrees, and I've just rounded that to the nearest whole number. Okay, so now I can write down my final answer, and that is that the displacement equals, what did I get? 1,000 kilometres. 1,000 kilometres, and that's north 37 degrees towards east. So there is my final answer with a magnitude, the units, and the direction, and it's a specific direction, not just northeast. And so that is what you were required to do for a question like this on an assignment, a test, or an exam. Okay, let's have a look at another example. All right, here we go. A glider is flying at 40 kilometers per hour west, and the wind is blowing at 22 meters per second. That's annoying. We've got different units. We're going to have to convert one. Meters per second south, calculate the velocity. So velocity is really speed with a direction. And here we've got two different speeds. So I'm just going to have to put these two speeds together to find the resultant speed, velocity, okay? Now, one's in kilometres per hour, one's in metres per second. I'm going to need to convert them both to the same units. So converting between metres per second and kilometres per hour, this is something you're going to have to make sure that you remember for this course. So metres per second to kilometres per hour is, so from metres per second to kilometres per hour, we times by 3.6. So to go from kilometres per hour to metres per second, we divide by 3.6. Okay? So the general units that we use in this course, the standard units, are metres per second. So I'm going to go and convert the kilometres per hour one to metres per second. So let's go 40. So converting 2 meters per second, I divide by 3.6. So 40 divided by 3.6 equals 11. Let's stick with two significant figures to match the 40. So it's 11.1, but we'll just go 11 meters per second. What is this? West. Okay. Now, just a side note, writing meters seconds to the negative 1 is exactly the same as writing meters per second. So do one or the other, not both. Right, now let's do the question. So I've got a westerly component and I've got a southerly component. To make this easier for me, I'm going to do the southerly component first, okay? That's going to help me with my direction later, so I don't have to change it from west-south to southwest. So I have to not look at my phone because I keep getting notifications and it's very distracting. All right. So 22 meters per second south. I'm going to go south first. So south is sort of downways if we're doing it on 2D paper. And that's 22. And then we're going 11 meters per second west. Now, the resultant component is the velocity that way. Wonderful. Now, let's find out first the value of that velocity. So the magnitude is what we're finding out. And I do that using Pythagoras. So the velocity squared is the two individual velocities. squared, just like the last example. So 11 squared plus 22 squared, 11 squared plus 22 squared equals 605. So to find v, I need the square root of that, and the square root of 605 is 24.6. And I'm going to 3 significant figures now, which is a bit naughty, but I just don't really like using 2 significant figures. It just feels like not enough. Alright, so that's meters per second, isn't it? Now, I can't just give the velocity without a direction because velocity is a vector and it needs a direction. So, which angle am I working with? Well, my starting point was here, and the angle always goes in the starting point. And I ended up here, so this is the angle I'm interested in. So again, it's pretty much always opposite and adjacent in these questions. Oh, whoopsie, what's happened? So the opposite is my 11, the adjacent is 22. So we're almost always using tan in this course when we're doing these. So the equation is tan, tan theta equals opposite over adjacent. So my opposite is 11 over 22. Now I just want theta, I don't want tan theta, so I'm moving the tan to the other side. The opposite of tan is inverse tan of 11 over 22. And that will give me 26.8 degrees. Fantastic. So now just to write out the final answer, the velocity with a nice little arrow, which Pete will like. The velocity is 24.6 meters per second, and it's southwest, so south 26.8 degrees towards west. Hooray! Okay, that's that. Now you probably need to pause that if you're still copying that down, sorry. The questions that you should practice are in the physics questions book. Physics questions book. I've just ignored this subtracting vectors page because what is it? I think it's like it says, okay, no, I will do an example of that. I'll tell you which questions we're doing first. All right, so physics questions book, page 4 and 5, do the addition of vectors questions. The ones above that are the ones that you do using a protractor, which really you're never going to have to do in this course. So addition of vectors. All of these will use tan theta. So you can do questions 1 through 8. If you want to have a look at components of vectors, have a crack at questions 9 and 10 as well. Those questions are definitely rarer in terms of what happens in the course. Now just quickly, I think this subtracting vectors thing is sort of like if you go, let's say 10 kilometres north, 3 kilometres, I don't know, west, whatever, and then 5 kilometres south. So that's going to look like 10 north, 3 west, 5 south. And it's like, oh, how do I calculate my velocity there? Well, you sort of just subtract the north and south. If we've got 5 south and this is 10 north, then on the little triangle, that's just going to be 5, isn't it? So we just subtract the north and the south, which gives us 5 kilometres north, 3 kilometres west. I think that's what that's saying. That does come up a little bit, but not much. I'm going to stop the video now. I do want to do the next bit, which is kinematics and displacement time graphs, but I just sort of want to check my video quality before I make it much longer and try and upload it, because I've been having some issues with YouTube and I don't know, we'll see how this goes. But thank you for listening. Feel free to leave me feedback. Don't be too mean, this is my first go. If you have questions, you can post them underneath the video, or you can contact me or your teacher. Okay, thank you very much. Here we go. How do I stop the video? It's going well. Oh, go away. Okay, goodbye.